Okay, Assalamualaikum and good morning. So guys, I'm Dr. Atika. So I will teach you chapter 2. So before this, you have chapter 1 and you have Dr. Yanti. So now we have chapter 2. What we have here is analysis of variance ANOVA. So in chapter 1, actually what you have in your chapter 1 is when you want to compare two population mean. For example, you have mu1 and mu2 and you want to compare the similarity between these two mu, you can use the hypothesis testing, right? So in this chapter, how about you want to compare mu1 equals to mu2 equals to mu3 equals to mu4 and so on. How about you have more than two population mean? How you want to compare? So because hypothesis testing is limited to two population mean. So we will use what we call it as ANOVA to compare more than two population mean. Compare what? Compare the similarity. Okay, more than two population mean. So ANOVA is a short form of analysis of variance. We will use variance to compare the similarity of the population mean more than two population. Right? So next we have analysis of variance. Okay, at the end of this chapter, you should be able to use one-way ANOVA to determine if there is a significant difference among three or more means. Okay, three or more means. And another one is use the two-way ANOVA. So we will have one-way ANOVA and two-way ANOVA. Okay. Right. So next, introduction to ANOVA. So first we should know what is the purpose of the ANOVA and what is the assumption that we have in the ANOVA, and we should know how to use hypothesis testing procedure to solve the ANOVA. So we still use the hypothesis testing procedure. So let's recall back the hypothesis testing procedure. Number 1 is your H null and H1. You must have your H null and H1. You must have your hypothesis and the alternative hypothesis. Step number 2 is your p-value. So p-value you can get from your Excel, the significant value. And then step number 3, you compare. Okay. If p-value less than or equal to alpha, we reject the H null. Okay, and then step number 4 is your conclusion. So we will still use this step to solve the ANOVA. Alright, analysis of ANOVA. What is the purpose of the ANOVA? So the purpose of ANOVA is, first, we want to compare the difference of more than two population mean. So example, you have mu1, you have mu2, mu3 and mu4. You want to know, is there the similarity between these four mu? So we can use ANOVA. Right? Also known as factorial experiments. Okay, the approach that allows us to use sample data to see if the values of more than the population means are likely to be different from each other. Okay, this name ANOVA is derived from the fact that in order to test for the statistical significance between means, okay, we want to test the statistical significance between means, but we were actually comparing the variance. So when we talk about variance, we will use the F distribution. Okay, next. See, there are two types of ANOVA as I mentioned just now, one-way ANOVA and two-way ANOVA. So what is the difference between one-way ANOVA and two-way ANOVA is, one-way ANOVA involve one factor, means that one independent variable. Two-way ANOVA involve two factors, means that two independent variables, and we want to know the interaction effect. Okay, so one-way, one factor means that one independent variable. I will use IV for independent variable. For two-way, we have two factors. and you have two independent variable, and we want to test the interaction. Is there any interaction between the two factors? So that one is into Way Anova. Okay, these are the difference between hypothesis testing and the one-way ANOVA and two-way ANOVA. Okay. Right, the procedure for ANOVA test, the same, right? First, you must formulate your H null and your H1. And then construct the ANOVA table. Normally, we will construct the ANOVA table using Excel. Okay. Next step is actually the p-value, because this one is the manual part. And then the last part here, you compare. And here your conclusion. So now, let's look at one-way ANOVA. So in one-way ANOVA, you should know how to determine if there is significant difference among the three or more population mean. So in one-way ANOVA, we want to test mu1 equals to mu3 equals mu2 equals to mu3 or until your mu(n). Similar or not? Is there any significant difference or not between this population mean? Okay, so one-way ANOVA. So what is one-way ANOVA? One-way ANOVA, as I mentioned, is involve only one factor. What does it mean only one factor? Means that only one independent variable. Okay, and we have only one dependent variable. Okay, only one independent variable. So these are the assumptions that we have in one-way ANOVA. So the assumption is the population must follow normal distribution. Okay, the samples are drawn randomly and each sample is independent. So means that one sample with this sample is independent. Okay, next, all the population must have the same unknown population variances. So these are the assumptions. So must have the same population variances. So these are the tabulation of data. So your data, we will have here treatment and replicate. Replicate is how many times you run the experiment. Treatment is based on your independent variable. Okay, so this is, you have to know when you want to do the manual part. So what are the model? So the model in ANOVA, you will have here mu plus alpha I plus epsilon I G, where the alpha here is the treatment, epsilon here is the error. Okay. So, right. So now we will have the step number 1. Step number 1 is your H null and H1. So H null, what we want to test? We want to test, is there any difference between the population mean? So your H null is always equal. So your H null is mu1 equals to mu2 until mu k. K is how many sample you have. Okay, how many population you have. For example, you want to compare 3 populations, so mu1 equals to mu2 equals to mu3. Or you can write down all population means are equal. Okay, or no differences between population mean or no variation in means. So either one. You can use notation, you also can use the words. If our H null is equal, how about the H1? H1 is the alternative. So alternative, if H null is equal, H1 is not equal. So mu I is not equals to mu j for at least 1. So at least 1, not all is not different. For at least one population mean is not different. So you can write down like this or you can write down in words. For example, at least one population mean is different. Okay, you must have the word at least one population mean is different. Or there are differences between population means. There are significant difference between the population means. So okay, it give the same meaning. Right. So these are the hypotheses. After hypothesis, you want to construct the ANOVA table. So in manually, this will be your ANOVA table. So ANOVA table here is treatment, error and total. Okay. SSTR, sum square treatment, sum square total, sum square error. This one is degree of freedom. K is your treatment. Alright, and then this one is your F test. This one is the critical value. Okay, so in this subtopic, in this chapter for this course, we will construct this Anova table using Excel. You don't have to calculate manually here, right? We will substitute the data into the Excel and then we will come out with this one-way Anova table. So this Anova table will be given in Excel output. You have to know how to put the data into the Excel and then come out with this Anova table. Okay, so these are the formula how we get all the values in the Anova table. So let's look at the example. Okay, example 4.1. Okay, an experiment was performed to determine whether the annealing temperature of ductile iron affects its tensile strength. So, determine whether the temperature affects the strength. Okay, 5 specimens were annealed at each of 4 temperatures. So, 5 specimens and we have 4 temperatures. The tensile strength was measured for each temperature. The results are presented as follows. So, the results here, we have temperature and tensile strength. We have different temperature and the effect to the tensile strength. So, from here, we know that we want to know is there any effect to the tensile strength if we use different temperature. So, the temperature here, we have 1, 2, 3, 4. So, the temperature here is your factor. One factor only, that is the temperature. So, this temperature give effect or not to the tensile strength. So, one factor means that the temperature will be your independent variable. So, is that temperature give effect to the tensile strength? So, tensile strength will be your dependent variable, the response. Okay, so in independent, we have the treatment. So 1, 2, 3, 4. So we have 4 treatment. K is equals to 4. Right, so how about this one? Treatment 1, 750. How many specimen they take? 5. Means that for each treatment, they take 5 replications. They take 5 specimens. Okay, so treatment number 2, 800 degrees C, also 5 specimens. Treatment 3, 850, also 5. And treatment 4, 900 degrees C, also 5 treatment. Okay. Write down the model assumption. Okay, I'll skip this one. Okay, state the dependent and the independent. So, the dependent is the tensile strength. Independent is the temperature. So, C. Perform the ANOVA method and test the hypothesis at 0.01 level of significance that the mean data provided by the tensile strength is the same for all 4 temperature. So, at alpha 0.01, the question asks you to test the mean. The mean for all the tensile strength, for 4 temperatures, same or not. We have 4 temperatures, right? Just now. 1, 2, 3, 4. So, the question asks you to test mu1 equals to mu3 equals to mu2 equals to mu4 or not. So, you have to test this one. Okay. So, the solution is, so these are the model. I'll skip this one. Okay, independent variable, temperature. Dependent is the tensile strength. Okay. So, step number 1 is your hypothesis. So, what we want to test? We want to test is there any similarity between the population mean. So, mu1 equals to mu2 equals to mu4, or you can write down all population mean is similar. Okay. So here you can write down also at least one population mean is different. So it's up to you. If you want to put notation also can. If you want to write down in words also can. So step number 2. So in manually we will calculate all the values to come out with this ANOVA table, and then we compare the F test. But in our case, we will do the P value. So we will get later on how to conduct the one-way ANOVA using Excel. So this, okay. these are the exercise. So we will do the exercise using the Excel. How to conduct one-way ANOVA using Excel, using this exercise. Okay. So let's look at how to do this exercise using Microsoft Office Excel. Try to do example using the Microsoft Office Excel. So the example just now is here. Okay. About the temperature and the tensile strength. Okay, so I'll put the example into the Word. So an experiment was performed here, and then temperature and the tensile strength. Okay, so what you have to do is you open the Excel, right? Open the Excel, and then you insert the data. So we have the data here. This is our treatment. Okay, treatment 1, treatment 2, treatment 3, treatment 4, and then this is our replication, the tensile strength. Now we want to perform using Excel, the one-way ANOVA. So what you have to do is, after you insert the data here, and then you go to data, okay, and here you will have data analysis. So you click this data analysis. Okay, so when you click this data analysis, these windows will appear, and then you choose ANOVA single factor for one-way ANOVA, and then you click OK. Okay, these windows will pop out. So put here, these windows will pop out. See, the input range. So the input range is your data. So you click here, and then you select your data. Select also with the treatment. Okay, then you click here, and then group by, okay, our data now by row. One treatment, okay, by row. Row 1, row 2, row 3, row 4. So it is grouped by row. Okay, and then tick label in the first column. Why? Because we have the temperature here, the first column, and then we use alpha 0. So look at our exercise just now. Test the hypothesis at alpha 0.01. Okay, so here you put alpha 0.01. Okay, output range is where you want to put your output, the result. So I want to put my result here in the same sheet. So I want to put my result here. Okay, and then you just click OK. Then the result will appear here. This is your ANOVA table using the Excel, this one. This is the ANOVA table. So you don't have to calculate the ANOVA table, the ANOVA. So the Excel give you the ANOVA table. So now here you have the F test, and we have the P value, F critical value also. So let's copy this one. Copy and then put it into our words. Okay, I put as picture. Okay, now we want to test the hypothesis at alpha 0.01 that the mean data provided by the test result is the same for all the temperatures. So what you need to do, you have the step 1, your H null and H1. So your H null is, I put all population mean is similar, and my H1 is at least one population mean is different. Okay, you also can put the symbol, right? So step number 2 is the p-value. So p-value is equals to 0.0013. Okay, so we have here p-value. P-value 0.0013. So compare p-value with our alpha. Since the p-value equals to 0.0013 less than or greater than alpha equals to 0.01, what you have to do is you have to reject H null. Okay, what will happen if you reject H null is, okay, you reject this H null, you reject this one. So what will happen? At least one population mean is different. So there is a difference between the population mean. So the conclusion is at alpha 0.01, at least one population mean is different. Okay, so there is significant difference among the population mean, right? So this is the example 1, how you want to conduct the conduct the one-way ANOVA using Excel. Exercise. So this exercise 4.2, I will put the exercise into the Word. So suppose the Computerized Vehicle Inspection Center, Puspakom, wants to examine the safety of private cars between Myvi, Persona and Toyota Camry. 3 samples of pressure applied to the driver's head during a crash test from each type of car are collected and the data is given in the table here. Okay, we have 3 car, Myvi, Persona and Camry. So the data here is the pressure, right? So program Myvi, Persona, Toyota Camry is the private cars, and then the number here represent the pressure that applied to the driver's head during the crash test. Okay. Number 1, identify the control and response variable. Control is actually the independent variable. Response is actually the dependent variable. So what is the independent here? The independent is the private cars. Okay. And then the response is the pressure. So the pressure is depends on the type of the private car. So the control independent will be the private cars. Right. And then the dependent is the pressure. Okay, so how many treatments involved in this experiment and how many applications involved in each treatment? So treatment come from the independent variable. Private cars is the independent. So how many private cars we have? We have 3. So treatments is 3. So what is the treatment? Treatment is Myvi, Persona and Camry. Okay, next, how many replications involved? Applications means that for each treatment, how many experiment you do for each treatment. For example, Myvi, how many data we have? 3. So replications is equals to 3. Right. C. At at a significant level 3%, test whether the mean pressure applied to driver's head is equal for each type of car. So they ask you to test the mean is similar or not for the 3 different type of private cars. So you have to test. So what did I do here is we put the hypothesis first. So the H null is all population mean is similar. So the H1 is the alternative. At least one population mean is different. So step number 2 is your p-value. So where can we get the p-value? We substitute the data into the Excel and construct the Anova table. So and then we can get the p-value. So you go to the Excel, you substitute the data. Okay, and then you go to data analysis and you choose Anova single factor and you select your data in the input range, and then you group your data by column now because the data here is by column, and then label in the first row alpha. How many percent just now? Alpha is 3%. So alpha here is 0.03, and then the output range, I want my output to be here, and then click OK. Alright, so this is your Anova table. Right, this is your Anova table. So you copy your Anova table here, put it into the words. Paste as, I want to paste as picture. Paste as picture. Okay, so now we have the p-value. So the p-value is equals to 0.0012. 0.0012. So you reject or you accept the H null. So since the p-value is 0.0012 less than the alpha equals to 0.03, you have to reject H null. Okay, so what will happen if you reject H null? So you reject this H null. So your conclusion is at least one population mean is different. So at alpha 0.03. At least one population mean is difference. Means that we have three private cars, right? So means that the three different private cars give the different pressure to the driver's head. So different cars give the different pressure, right? So that is the uh, analysis of variance for one-way ANOVA. So here we have exercise number 2. So you can try on your own exercise number 2. So after this, you will have your lab sheet 2. So please try your lab sheet 2 and submit the lab sheet 2 in words. Alright, if you do in Excel, you copy like I did just now into the words, and then you combine and then you export the word into the PDF. Okay, so thank you.